Section 10.1, I'm going to take a look at 4 problems. The first one's going to ask you to find the angle between two given lines. Second one will ask you to find this, given a triangle, find the slope of all 3 of these line segments, and then use that slope to find the angle of all the interior angles, kind of like this one's doing, just adding an extra step to it. Third problem is going to ask you to find the distance between a given point and a given line, so just using the formula. And then the last one is going to ask you to find the area of a triangle with the vertices, and then they give you 3 of them, obviously for a triangle, using the equation to find the shortest distance between a point and a line. In other words, the easiest thing to do would be to do the matrix and doing the determinant thing like we did last chapter. That's not what they want you to do here. We did it in class, and I'll show you again, but they want you to use this formula, the distance between a point and a line formula. So it's just another way of finding the area of a triangle, and we'll look at that when we get there. Alright, so starting out with the first one, find the angle theta between two given lines, 2x minus y equals 2 and 4x plus 3y equals 24. And of course I want to use this formula. I want to use the tangent of theta is equal to absolute value of slope 1 minus slope 2 divided by 1 plus slope 1 times slope 2. And the good news is it doesn't matter which one's slope 1 or slope 2 because you're going to take the absolute value of it. So even if you have those reversed, it won't make a difference. It obviously won't make a difference if I reverse those because you're still multiplying. So my job is I need to take both of these lines and figure out what the slope is. So let's say I just added the y over to the right side, subtracted the 2 over to the left side. Really don't care about the 2, this 2 so much. As long as y is isolated, I know that that's the slope. So that's either m1 or m2, whichever you want it to be. For this one, I would have to subtract 4x, and then I would have to go ahead and divide both sides by 3. And realistically, I could care less what that number is for this particular problem. All I care about is the slope. So there are the 2 numbers that I need to plug in here. Like I said, it doesn't matter which one's which. So I have the tangent of theta is equal to, I'm going to say m1 is 2. So 2 minus a negative 4/3, be careful with the double negative, divided by 1 plus 2 times negative 4/3. And then I'll eventually be taking the absolute value of that. So before I can do anything with the absolute value, remember you have to simplify this down to one number if you can in the numerator and the denominator. So, got the tangent of theta is equal to, if I had a common denominator, this would be 6 over 3 plus 4 over 3, or that's going to eventually give me 10/3 in the numerator. Multiplying these together, I can see it's negative 8/3 plus 3/3, or that's going to eventually give me negative 5/3. And then continuing to simplify, I've got the tangent of theta is equal to, if I divide and multiply by the reciprocal, those 3's are going to cancel. I end up with negative 2. I'm taking the absolute value of it. So it eventually will simplify down to the tangent of theta is equal to 2. And now, of course, I do the tangent inverse of both sides. And taking out your calculator, making sure you're in degrees. We're going to give the answer in both degrees and radians. But I do tangent inverse of 2, hit enter, and there is my angle in degrees. It's 63.4 degrees. If I want to change that to radians, I can go ahead and just multiply that by pi, divide by 180, and I can say that that's also 1.107 radians. I believe the ones that you do in the homework ask you for both, so go ahead and give both. Alright, there's the answer for the first one. Alright, so move on to the second one. It says find the slope of each side of the triangle and use the slopes to find the measure of the interior angle. So we'll go ahead and find the slopes for all these. I'm going to go ahead and call this one A. Let's go ahead and call this one B and this one C, just so I can refer to A, B, B, C, so on. Alright, so let's go ahead and find the slope of, well, let's start with AB. So remember, slope is y minus y divided by x minus x. So doing this, I'm going to start with A. My slope would be 4 minus 2 divided by negative 3 minus a negative 2 or plus 2. So my slope for AB looks like it's 2 over negative 1 or it's negative 2. If I move on to BC, my slope is going to be 2 minus 1 divided by negative 2 minus 2. Or that's going to give me negative 1/4. And then I'll move on to AC, my last one. And finding the slope for that one, it is going to be 4 minus 1, or 3, divided by negative 3 minus 2. And so it ends up giving me negative 3/5. So there's the first thing that they were asking for. Find the slopes of all of the line segments, and there it is. Now it's going to ask me to use those slopes to find the measure of the interior angles. And basically I'm doing the same thing I did up here. I'm just going to do it 3 times. And then I have to be a little bit careful when I think about this. Because I'm taking the absolute value, my answer is always going to be something less than 90 degrees. So if you look at this triangle, when you run into that angle, that looks like it's obtuse, and it is. The calculator is not quite going to give me the right answer. It's going to get me close, but I'm going to have to slow down and think about this one for a little bit. All right, so let's ignore that for now and go ahead and start looking at it. All right, so let's say I want to find angle A to start with. Got to find all of them, but let's start with A. Well, look at the line segments that kind of shape that angle. It's AB and it's AC. So I'm going to need to use these 2 slopes to figure out angle A. So for angle A, my work is going to be the tangent of theta is equal to absolute value of, and again I'm using these 2 numbers, so negative 2 minus a negative or plus 3/5 divided by 1 plus negative 2 times negative 3/5. And so then I need to go ahead and I need to try to simplify that. And so if I get myself common denominators and so on, I'm going to have the tangent of theta is equal to, that's going to be negative 10/5 plus 3/5, so negative 7/5. Realistically, because of the absolute value, if I wanted to drop a negative off, I could, but I'm going to wait till the very end, like I usually should. Multiplying down here, they're both negative, so this is going to give me a positive 6/5 plus 5/5, or I should end up with 11/5. And then the 5s will end up canceling when I multiply by the reciprocal, and so eventually I'm going to get the tangent of theta is equal to positive 7/11. And then I would go ahead and use my calculator. Now angle A looks like it's acute, so this answer that the calculator gives me will actually be right. So tangent inverse of 7/11, and it's going to be, angle A is approximately 32.5 degrees. All right, and if that made sense what we did there, that's great. That means you know what you're doing. Angle B, angle C, shouldn't be any trouble. It's just doing the same work. I'm going to jump down to angle C now because I can see that that's the other acute one. I'll wait for the one that's not necessarily complicated, but I have to think about at the end. So angle C. This time I'm going to do the tangent of theta is equal to, look at what side lengths form that angle. It's BC, AC. So it's these 2 that I now want to use. So its tangent of theta is equal to, order doesn't make a difference, it's negative 1/4 minus a negative or plus 3/5 divided by 1 plus negative 1/4 times negative 3/5. And again, a little bit of simplifying work to do. So if I get myself a common denominator, it looks like it would be, I'm going to do this without showing my work if that's okay with you. This is going to end up being negative 5/20, 12/20. So it's going to eventually give me 7/20. Again, if you want to show your work, you're more than welcome to do that. I'm just trying to save myself some room here. All right, in the denominator, if I multiply, they're both negative, so that will cancel. It's going to end up giving me 3/20. This is 20/20, or I have 23/20. Absolute value won't make a difference here. They're both positive anyway. This eventually is going to give me the tangent of theta is equal to 7/23. And so again, I'll pull out the calculator, and this time do tangent inverse of 7/23, and it looks like it's 16.9 degrees. Now realistically, since I know the area of a triangle is 180 degrees, I could stop right here, say 180 minus 32.5 minus 16.9, and I would get what angle B is. I'm going to run through and show you how you do have to be a little bit careful sometimes, and looking at the picture if they provide it would be really helpful. Alright, so tangent of theta is equal to, for angle B, it looks like it's AB and BC. So it's those 2. that I want to use. So it's going to be negative 2 minus a negative or plus 1/4 divided by 1 plus negative 2 times negative 1/4. Alright, and then simplifying, I know that this is negative 8/4. 1/4 is going to give me negative 7/4 in the numerator. In the denominator, if I multiply these together, they're both negative, so again it turns to positive 1/2 plus 2/2, or this should be 3/2. And then if I multiply by the reciprocal, I'm going to end up with negative 7/4 times 2/3. And I can see that this would reduce down to a 2, and I'm going to end up with negative 7/6. Again, I'm taking the absolute value of that, so it becomes positive 7/6. And so when I go to type in my tangent inverse of the positive 7/6, by rule, when we do the absolute value, anytime you're finding the angle between two lines, they're always going to give you the acute angle. So when we say that it's 49.4 degrees, realistically that's not what we want. For this one, imagine two lines intersecting. If we're saying that this is 49.4 degrees, this is actually the angle that we want. Well, I know they form 180, so I can take 180 minus that angle. And the angle I'm really looking for, angle B, is really 130.6 degrees. Alright, so hopefully that made sense. Like I said, if you're doing this on the test, you could easily find the first two and then just immediately subtract from 180. Alright, on to the third one. Finding the distance between a point and a line. Just have to use the formula. So your distance formula in the numerator, it's the absolute value of A times x sub 1 plus b times y sub 1 plus c divided by the square root of a squared plus b squared. So basically just have to remember that formula. You've got your point, this is your x1, y1, and then the thing you really need to be careful with before you start plugging numbers in is your line needs to equal 0. You know, normally you say it's got to be y equals to, it should be slope-intercept form. Not for this formula. For this formula it has to equal 0. And you can move all of your information to whichever side you want. So if you want to move x and y over to the right or the 20 over to the left, it's going to be the same thing. You say, well, no, it's not because the signs are different. That's true, but that's why you're taking the absolute value of the numerator. That'll make the number the same regardless of how you do it. So there's the point that you want. There's the line that you want. And that's an easy thing to make a mistake on, to not set it equal to 0. Alright, so our distance is equal to a, which is the coefficient in front of the x variable, so it's 1. So absolute value of 1 times the x value of the point, so 4, plus b, which is actually a negative 1, times the y value, which is 2, plus c, which is actually negative 20. Take the absolute value of that, divide by the square root of a, which is 1, squared, plus b, which is negative 1, squared. And now it's more just simplifying it. So in the numerator I've got 4 minus 2 minus 20, absolute value of all that, divided by the square root of 1 plus 1, or 2. And it looks like if we added those two, I get 2 minus 20 should give me the absolute value of negative 18 over the square root of 2. I know that that's really just 18, and I have to rationalize, so it's 18 squared roots of 2 over 2. And now I can simplify here and say that it's 9 square roots of 2. And that would be the distance between that point and that line, the shortest distance. Alright, so now we're going to use that idea to help us find the area of a triangle. So it's going to ask us to find the area of a triangle with the 3 given vertices using the equation, basically saying this one, using this equation to find the shortest distance between a point and a line, which is going to actually give you the altitude. So this is not what the triangle would look like if you drew it out, but I'm just going to draw something so I have something to look at. Let's say that I was given these 3 vertices. What you are asked to do is pick 2 of them to be the base, 2 of the vertices. So let's say that this is my base right here. Well, if you're finding the area of a triangle, I know the area of a triangle is 1/2 base times height. Well, I've got the 1/2 that's given. I've got the base, it's right here. I just have to find the distance between those two. What I would need is the height. Well, the height happens to be that length right there, which forms a right angle, which happens to be the shortest distance between this point and this line. So what do I have to do? I have to come up with the length of the base, So I need to know those 2 points, and you can use whichever 2 points you want as your base. And then you need to find the altitude with the other point, and then you have to come up with an equation of that base. So I'm going to use these 2 points as my base. I know the triangle, if you draw it out, is not going to look like this, nothing like it, but the idea is the same. So to find the length of the base, that is going to be your regular distance formula, square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. So the distance is equal to the square root of x1 minus x2, doesn't matter the order that you do it because you're squaring it, so it's going to make it positive anyway, plus, and then subtract the y values, again, order doesn't matter, and then square it. So it looks like it's going to be 3 squared or 9, 2 squared or 4, or this eventually is going to give me the square root of 13. That is my base number here. The only thing I have left to do is figure out what is the height. And now to find the height, I have to do this. Well, what do I have to do? I have to have a point. Since I use these 2 points for the base, that means this is the other point. So there's my point, and then I have to have an equation of a line, which is this. So now using these 2 points, I have to write a kind of like a y equals mx plus b equation. So I want to find their slope. So the slope of these 2 points, if I take y value minus y value, is going to be 2, divided by x value minus x value is 3. So this is the slope of base. And so that means I have y is equal to 2/3 x plus b. And I'm going to have to figure out what b is. I use those 2 points, so I can use either one of those 2 points to plug in here. I'm going to pick 3 and 10. So plug in 10 for y, 3 for x. Of course, those 3's cancel. It looks like b is going to equal 8 after I subtract 2. So the equation of that line, or that base, is y equals 2/3 x plus 8. Now remember, that equation has to equal 0. So most of us will just subtract y, and that's right, there's nothing wrong with doing that, or you can move everything over to the left side if you prefer that. What I would recommend doing so you don't have to deal with fractions is multiply everything by 3, or whatever the least common denominator is. That's not going to change the 0. That'll make that 2x minus 3y plus 24. It just gets rid of the fractions, which tends to make things a little easier. Alright, and then remember that the point that you're dealing with over here is negative 4, 5. So here is the point that I want to deal with. And now using these 2 things, I'm going to run through and find the distance between that point and that line. And when I find that, that'll give me the height. And then eventually I'll take 1/2 times the base times whatever this height is. So now looking for the height. Alright, it's going to be distance is equal to absolute value of a, which for this equation is 2, times x sub 1, which is negative 4, plus b, which is negative 3, times y sub 1, which is negative 5, plus c, which is 24. An absolute value of that, divided by the square root of a squared and b squared, so 2 squared and negative 3 squared. And simplifying my numerator, let's go down here, it's going to give me negative 8 plus 15 plus 24, divided by, this is going to be 4 and 9, so square root of 13. And if I add my numerators together, it looks like I've got 7 here plus 24, so I end up with 31, and then the absolute value of 31 is still 31. So there is my height. And you should notice that when you're doing this, notice that what you did here and you did here is basically the same thing. That always works out nice because that means I don't have to rationalize this, because what's going to happen when I multiply those 2 things together, they're going to cancel. And that should always happen when you're doing this. It's not saying that this will always turn out to be exactly the same number as this. If it doesn't, that means this should simplify so that it eventually will simplify into that. Alright, so using my area equation now, its area is equal to 1/2 times the base, which was the square root of 13, times the height, which was 31 square roots of 13. Of course, the radicals are going to cancel, and I end up with 31 over 2 units squared, whatever the units are. So there's a little bit of a concept that you have to understand what you're doing here, but once you get the concept down and you know how to find the length of the base and the height, it's not too terrible of a problem. You just, like I said, you have to understand the concept. right, those are the 4 problems for 10.1.